One day, the sun will die. As it does, it's going to swell into a red giant, over 100 times its size at the moment, and engulf the Earth. It's going to boil our oceans, burn the planet to a crisp, and eliminate all life on our surface. In fact, one day, the last star in the universe will die. And as it goes out, the universe itself will be cast into eternal darkness. There will be nothing left. So the question is, when will the universe die? I'm Damon Scotting, and this is Astronomical. Now, in the first episode, we look back to the birth of our universe and how, after 13.8 billion years, we got to where we are today. Now, in the series finale, we're going to look forward in time and figure out just how and when the universe will end. So let's start with a small leap forward in time. How different will our universe look in just 10,000 years? Come with me as we venture into the future. In 10,000 years, the red supergiant Antares will go supernova. It is a star 12 times the mass of our own Sun, with a diameter roughly 500 times larger. If it were to swap places with our Sun, then it would extend beyond the current orbit of Mars. The resultant supernova will likely shine as bright as a full moon and be visible to the naked eye during the daytime. There will be a simultaneous total solar eclipse and transit of Venus. Vega will become the new North Star as constellations start to become unrecognisable. This will be the end of the projected lifespan of the Svalbard Global Seed Vault. The vault preserves an enormous variety of plants and seeds from the event of a global crisis. The Sahara will become tropical. Voyager 1 will move to within 3.4 light years of our nearest stellar neighbour, Proxima Centauri. The Chernobyl exclusion zone will return to normal levels of radiation. The northern polar ice cap on Mars will begin to recede as the red planet reaches a warming peak in its northern hemisphere. "10,000 years was the most probable lifespan of a civilization according to the Frank Drake equation. But if we make it beyond that, to say 1,000,000 years, then we will be around to witness some truly special events. After 1,000,000 years, Neil Armstrong's and the rest of the Apollo moonwalkers' footprints will have disappeared from the surface. The Great Pyramids of Giza will have eroded beyond recognition. The stars in our night sky will have moved independently at different speeds throughout our Milky Way. This will lead to constellations no longer resembling the way they appear to us now. By this point, the red supergiant star Betelgeuse will have exploded into a supernova. For at least a few months, the supernova will be visible to the naked eye on Earth. There will now be a void in the shoulder of Orion. We will have surpassed the time required to terraform Mars. This is an optimistic and pessimistic moment in time, depending on the way you look at it. It is the shortest estimated time by which humanity could potentially colonise our Milky Way galaxy, and become capable of harnessing all the energy of the galaxy. This is largely based on the assumption that we will be capable of reaching a velocity that is at least 10% the speed of light. But there is also a 95% probability that humanity will be extinct by this date, according to the Doomsday argument. There will likely have been at least one eruption of a super volcano. Mars's two moons, Phobos and Deimos, will collide and form a ring encircling the red planet. Whilst much further into the future, 100 million years or so, the rings of Saturn will have disappeared. The Sun's luminosity will have increased by 1%. This is the beginning of the end for our solar system. As the Sun grows in size and luminosity, the region around it, known as the habitable zone, where it's not too hot and not too cold, will expand with it, meaning the Earth will likely boil away. So in order for us to stay alive, to stay on a habitable world, we will need to move the Earth further away from the Sun. This will require a grand astro-engineering project. We'll need to use asteroids to give us gravity assists to move further away from the Sun. In 5 billion years, one of the greatest night sky spectacles will take place as the Andromeda Galaxy and Milky Way merge. Over the course of the next few billion years, these two galaxies will engage in a beautiful celestial ballet. Very few stars will actually collide with one another whilst this is happening. This is due to the vast distances in between the stars. But there will be a considerable number of stars that are ejected from this new galaxy that is to be known as Milk-Dromeda. Now that the hydrogen supply at its core is exhausted, the Sun will start to leave the main sequence phase and evolve into a red giant. The Sun will engulf the Earth and Moon. By this point, however, any life that was left on the Earth will be long dead, due to the new searing temperatures on its surface. The Sun will swell to as large as 256 times its radius today. Although this is terrible news for our planet, assuming we cannot do anything to alter its distance from the Sun, this will be a new era of life elsewhere in the solar system, as moons such as Titan will likely reach surface temperatures that are now suitable for life. Now this is a very peculiar point in the life of the universe, because it can take one of three different routes, and this depends largely on the rate at which it continues to expand. The universe could end as early as 22 billion years from now, in what is known as the Big Rip. The Big Rip model of the universe is based off the idea that the expansion of our universe will start to increase to infinity in a finite time, meaning all matter in our universe, including every galaxy, star, subatomic particle, even space-time itself, will be ripped apart, leaving nothing behind. This idea depends on the amount of dark energy in our universe. This affects the rate at which the universe expands. So if dark energy can increase without limit, then we will reach a point where it will overcome all of the forces that hold our universe together. This is just one potential end to our universe. Now if the universe does continue to expand, then our nearest galactic groups will move so far apart from one another that we will no longer be able to see them. The redshift from these galaxies will be beyond our point of view, meaning any civilizations that are born after this point in time will look out into the universe and see only our local galactic group and think that is all there is and all there ever was. Galaxies are very far away from one another. It is unlikely that we will ever be able to venture to a galaxy outside our own local group, as the universe's continuous expansion is stretching us further and further apart, meaning we will need to be able to one day find a way to travel across these immense cosmic distances in a small region of time. If we don't, then they will have all moved well beyond our view. The universe contains somewhere in the order of 200 billion galaxies that we know of. Any newborn civilizations at this point will look out into the night sky and see only the few within our local group, and accept that this is all there is out there and all there ever has been, because there is no proof otherwise. Their entire universe will consist of the few trillion stars within our local group. However, if the universe does begin to stop expanding and instead starts contracting on itself, then this will be a far more optimistic end to our universe's life, as all the galaxies that were once too far from one another to see each other will now begin to contract and slowly coalesce until a point of single infinitely dense mass, and then perhaps a big bang. The universe will continue to repeat itself in what is known as the Big Crunch. The Big Crunch scenario assumes that the density of the matter in our universe is high enough that everything will soon begin to contract under the influence of gravity, overcoming the expansion of our universe. This theory is also referred to as the Big Bounce. The galaxies will all slowly start to merge together, and the temperature of the universe will increase so much that it will now be hotter than the surface of most stars, before eventually collapsing into a singularity, and then maybe, just maybe, producing another Big Bang. This could be the way in which our universe was formed. Perhaps this is the cycle of the universe. There is never an end, just a new beginning. But out of all of these potential outcomes, perhaps the most likely of them all is the Big Freeze. Otherwise known as the heat death of the universe, it's based on the idea that it will continue to expand forever. And at this point in time, 10,000 times the current age of the universe, no more stars will be born. It will be the end of the Saliferous era. There will be no more starlight in the universe, and it will be the beginning of the Degenerate era. All of the stars in the universe have now exhausted their fuel. In what was once a rich galaxy filled with trillions of stars, there are now only 100 remaining in our Milky Way. The longest living stars, such as the low-mass red dwarfs, have a lifespan that is approximately 10 to 20 trillion years. But soon they, alongside the white dwarfs, brown dwarfs and neutron stars, will all die out. The only new stars that will be born during this period are through incredibly rare star collisions. They will lead to supernovas, and a new star will be born, but will not last very long. One day, the last star will go out, and the universe will be cast into eternal darkness. This is the beginning of the black hole era. Now, at this long distant point in the future, the only source of fuel for an exotic civilization will be that from a rotating black hole. But even black holes die. After the last one has disappeared through Hawking radiation, there will be no more black holes left. At this point in time, it is 10,000 trillion, 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 trillion years into the future. Any hope of harnessing energy in this now bleak universe will likely come from using the rotational energy of a black hole. Black holes were once believed to be eternal, until Stephen Hawking discovered that along the event horizon of a black hole, the region known as the point of no return, there were interactions between particles and antiparticles. When the two separated on the very edge of the event horizon, one would be swallowed and trapped, whilst the other broke free. Through this process, black holes slowly release energy, and after incredibly, immensely, ridiculously long periods of time, they start to dissipate, and the universe becomes even emptier. As the last black hole dies, there is nothing remaining. This is now the Dark Era.
Now, the last possible outcome for the universe is the Big Freeze, otherwise known as the heat death. And this is based on the idea that the universe will continue to expand forever. And after the last particles are removed from existence, there will be nothing. No movement, no activity, no life. Time will have become meaningless. This will be the end of time.
Now, the end of the universe might seem pretty bleak. It might make you question, is there any meaning to life at all? Well, the answer is yes. Right now, we're at the beginning of our journey. We as a civilization have existed for the cosmic blink of an eye. The best is still yet to come. One day, we will venture to another solar system. One day, we may encounter alien life. One day, we will die. But our inevitable demise won't occur before we venture out to new worlds and new stars. 100 years ago, we didn't know there were other galaxies out there. 400 years ago, we believed we were at the center of our solar system. Imagine how small our universe would have seemed back then and how big it is now. Right now, we're living through the golden age of exploration. And you might take joy in the wonders the universe has waiting for us. We are just a few cosmic steps away from discovering them. I'm Damon Scotting, and this was Astronomical. And wonders lie ahead. Okay, so you may remember this spot from last week where I was filming and I got stuck in the mud. Well, today I was walking down the same field trying to get to the area where I want to film my final scene for Astronomical, like the season finale, and I got chased down by some cows. So now I tried to run down to this bank for shelter, and that did not work.
I've ripped my jeans. I have completely ripped my jeans. Oh no. You f***ing melon. Oh, head. Yeah, I have truly and completely
Okay, so 3, 2, and 1. One day, the sun will die.